Ever wonder just how critical power electronics is to our power systems? To give you some perspective, approximately 60% of the final electric energy used in developed countries is processed by a power electronic converter at least once. This means that power electronics play a pivotal role in power generation, power transmission, power system harmonics control, and power supply stability. Diving into the first application, power electronics in power generation, the role becomes even clearer. Take, for instance, the dynamic operations of hydroelectric and wind power due to natural conditions. The power generated by water is contingent on pressure and current velocity, while wind power is proportional to the cube of the wind velocity. Through power electronic devices, we can achieve variable speed constant frequency excitation, operating with maximum effective power to enhance power generation quality and efficiency. Modern power systems have evolved to include both conventional and renewable energy sources such as wind, solar PV, MHD, and fuel cells. Power electronics converters, or PECs, are the primary power converting devices for all these renewable energy sources, integrating them with the existing power grid. A PC consists of a power source, connected load, power electronics converter, and control unit. These devices are efficient, reliable, and have low voltage ride-through capability. Moreover, they can support reactive power injection to maintain the grid's voltage and frequency. Now, consider a wind energy plant. The main elements of a wind turbine system include a turbine, a gearbox, a generator, a power electronic system, and a transformer for grid connection. Here, a variable speed wind turbine configuration with full-scale power conversion connects the generator to the grid through a power converter. In a micro-hydro power plant, the back-to-back full converter plays a crucial role. The generated electric power is transferred via this converter. The machine-side converter controls the speed of the hydraulic turbine, while the grid-side converter regulates the DC bus voltage and controls the currents injected into the grid. Finally, let's turn our attention to solar power plants. Solar panels produce direct current which must be converted into alternating current to supply homes or the power grid. In conclusion, power electronics is an indispensable part of our power systems, contributing significantly to the development of more intelligent and sustainable power systems. From power generation to transmission, controlling power system harmonics and ensuring power supply stability, power electronics is at the heart of it all. The applications in wind energy plants, micro-hydro power plants, and solar power plants are just a few examples of its far-reaching influence.